Okay guys, so today we're going to solve the problem, validate binary search tree. So the question says, given the root of a binary tree, determine if it is a valid binary search tree, BST. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of a node contains only nodes with keys greater than the node's key. Both left and right subtrees must also be binary search trees. Okay, so what the question is saying is, basically we have to just check if the tree is a BST or not. So what BST says that you have its left node nodes, or all left child should be less than it and its right child should be greater than it. So for example, over here 2 is greater than 1 but is less than 3, so this is a BST, and we have to check it for even every subtree as well. So here we have 4 which is greater than 3 but less than 6, so this is a BST. This tree is a BST. But if we check over here, 5 is greater than 1 but 5 is also greater than 4, which is its right node. So this whole tree would not be a BST because of just this one connection. Okay. So how we'll solve this problem is we're gonna add each element to an array through in-order traversal. And when we do that, so basically when we append elements doing an in-order traversal, it gets added in a sorted manner. So what we'll do is we'll just go through the elements of the array, and we'll just check if the previous element is greater than the next element. If the previous is greater than next, then we'll just return a false, which would mean that this is not a BST. And if that's not the case for all the iterations, then we'll just return true. Okay, so let's solve this out. So first let's just create the in-order function, self comma root, and what we'll do is if not root return, then we'll just do a self dot in order of root dot left, then we'll be creating an array which I'll show you in just a minute, and we'll append the data to it, root dot val actually, so val, and then we'll just do a self dot in order of root dot right. Okay, yeah, and now over here, so now all the elements will be appended to the array in a sorted manner. So here we'll just create that array, self dot array, one second, yeah, arr is equal to, yeah, so we'll just create this array now, and yeah, then we'll call the function self dot in order of root. Okay, and now what we'll do is we'll just check. So for I in range length of self dot array of -1, if self dot array of I is greater than self dot array of I plus 1, what we'll do is we'll return a false, else we'll just return true. Over here we'll just return true, return false, otherwise we'll just return true, and this should be equal to over here. And so let's run the code. Yeah, and submitting it. Yeah, it's submitted, guys. So yeah guys, this is how you solve the problem, and if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.